Okay, circumference and arc length of circles, page 50 of your notebook. Remember all the parts that you need to have. When you're talking about circumference, you're talking about the length all the way around the whole circle. And when you're talking about arc length, you're just talking about how long is it from one little piece. So arc length is part of the circumference, but it's just a certain part depending on how many degrees the angle is. How many degrees your angle is. Alright, so circumference has a simple formula, pi times diameter. Sometimes you might see it as 2 times pi times radius, because when you say twice the radius, you get the diameter. But I always remember it as pi times diameter, because it's different, and I don't want to get it confused with anything dealing with radius and radius squared. So I just put pi times diameter. And there's 2 ways you can write this. So finding the circumference, if they ask for circumference, use the circumference formula. Seems easy enough. Circumference equals pi times diameter. So pi, you just leave off for right now. Let's see, circumference is pi times 20. And the ACT will leave their answer as 20 pi. Now, if you were actually wanting to say how long is it in inches around the circle, you don't want a 20 pi answer. You want something real and more tangible with it. So that's 62.8. 20 times pi in the calculator, 62.8 inches. So you could wrap a string around it and it would be 62.8 inches long. All right, but be aware that the ACT wants it like that with the pi. That's how they're going to do it. All right, so then number 2, same thing, same formula, circumference, pi times diameter. But this time I didn't give you the diameter, I gave you what? The radius. So it would be pi times, not the radius, I need the diameter. And the diameter would be twice that much, so 8. So 8 pi, or put it in the calculator, and it rounds off to 25.1. Alright, so that's approximate, rounded off. Alright, so what if I told you to work it backwards? Find the diameter. Well, there's not a diameter formula. Diameter is just diameter, but I gave you the circumference. So if you have a circumference in the problem, you're going to use the circumference formula. So circumference is pi times diameter. What is C? C is 26, so we're going to put the 26 here. And then pi times D. What am I trying to do? I'm trying to get D, diameter. So I got to get D by itself. I'm going to divide out pi. Divide out pi. So pi cancels right there. And I'm left with D equal to 26 over pi. And that is your ACT answer, just like that. Or if you round it off in the calculator, 8.3. Alright, then finally number 4 is kind of doing the same thing. Circumference equals 14 pi. Well, circumference equals pi times diameter. Well, look at it. Pi times diameter. What's the diameter? That's the 14. Alright, you could actually do the math. Circumference equals pi times diameter. So 14 pi. 14 pi times diameter, get diameter by itself, divide out pi, cancels, divide out pi, cancels. So the diameter is 14. But it's still just whatever's right next to pi right there. Save you a little time. Alright, then we deal with arc length. So I'm saying we've done these in the past where you found the degrees, but now how long is that in inches? And so the formula is almost the same as what you were just doing, except you have to do degree over 360. What are you doing with that fraction? It's the part over the whole. The whole amount in degrees is 360. What part do you have? In this problem it's 100. and then pi times diameter still. So this is saying a part of the whole circumference. This part was your circumference. So what fraction of the circumference do we have here? So our diameter, remember now, look at the drawing. Is that a diameter? No, that's a radius. So we need to put 8. So the ACT answer would be 2.2 pi, or put it all in the calculator, 6.98 or 7, since it rounds up. Okay, so almost the same formula, just need that little fraction in front of it. Here's one for you to try. Stop the video, see if you can do the same thing. Arc length, degree over 360 times pi times diameter. The degree, arc AB, is what we need. So what's the degree of that piece? If all this is 270, I need to say 360, take off 270, gives me 90 degrees. So that's my degrees. Over 360 times pi times diameter. Put the formula down, and hopefully you won't forget that you're using a diameter and not a radius. Put in the 16, and you're going to end up with 4 pi. Oh, how do I get that 4 pi? So right here, divide that, 90 divided by 360, and then jump over pi times 16, and you get 4. And so we haven't multiplied by pi, so pi is still sitting here waiting. This times 16 makes 4, so 4 pi is your ACT answer, or put it all in, 12.6 for your rounded off answer. All right, so when you're trying to get your pi answer, just put it in as skipping over the pi and not multiplying by pi yet. Alright, then here's a couple where they work them backwards. Find the radius, same thing, put the whole formula. Arc length is degree over 360 times pi times diameter. Arc length, AB is 26 inches. Since that's inches, you know that's an arc length. Alright, that's 26 inches out here, right? Alright, and we're looking for the degree. We got that. That's a central angle. It equals the arc. Remember that? Divide 360 times pi times diameter. Now, this could be a little bit of a nightmare. We're not going to make this one a pi answer. We're just going to put this in all in one shot. All of this in the calculator at one time. 120 divided by 360 times pi. 26 is just going to sit here. The diameter is going to just sit here. And you end up with a decimal of, I don't know. Let me put it in and see. Thought I had it written down. 120 divided by 360 times pi. And you get 1 point, and I'm going to give a bunch of decimal places, like 4 decimal places. 1.0472. Alright, that 9 makes it go up to a 2. Alright, so this is what we got. 26 equal to 1.0472, and then the D. I want to get diameter by itself, because eventually I'm going to make it into a radius. So now, what do I do to get D by itself? Just divide. 1.0472 cancels. 1.0472. The D is now by itself, and I'm going to divide that. This is 226 divided by, and you get 24.8 for your diameter. But what did they ask for? They asked for a radius. So we got to do one more thing. Divide it in half. It's a radius. So you get 12.4. Booyah. Okay. A lot of work, but you still got to do it. Okay. So next we have circumference given to us, but they want you to find the arc length. So this is actually going to be two kinds of formulas, two different formulas. If I'm giving you circumference, then let's start with that. If the circumference is 28 pi, then what's the formula? Circumference is pi times diameter. Well, there's the pi, so where's the diameter? 28 is the diameter, right? So we showed you how to divide that a minute ago. Diameter is 28, so that helps. Now we're going to find the arc length of AB, so we got to do the arc length formula. So I'm going to erase all this. My diameter is 28. Arc length formula. Degree, well, look up here. That's 90 degrees to match the angle. Over 360 times pi times diameter, 28. And if I don't type in pi, I'm 90 divided by 360 times just the 28. I get 7, so my answer is 7 pi. Or, if I put it in the calculator, I say times pi now. And 21.99 or 22, because it rounds off. Awesome. Alright, so how can we apply this? What is the shaded area? Seems easy enough. I got a big rectangle and I've got two half circles. Oh, we're not doing shaded area. Excuse me, I want the perimeter of the shaded area. So it's like I'm taking a walk around the edge, 20 feet that way. I'm going around the edge. That's not 8. 8 is the diameter, and I'm not going on the edge. I'm going this way. And then 20 down here, and then around the edge again. So we got to add up all those four sides. I've got a 20 and a 20 plus half a circle and half a circle. Well, what happens if I put those two halves together? I get a full circle. So I'm wanting the length around one full circle. What is that called? Circumference. And the diameter is 8. When they put it in the middle like that, that's 8. So the circumference is all I got to add. I don't have to add two halves. I can just make it the circumference. So let's see what the circumference is going to be. Formula, circumference, pi times diameter. So 8 pi. So you could have this answer written as 40 plus 8 pi on the ACT, right? Or if you put in 8 times pi, you get 25.1. So you could add that 25.1, and that's 65.1. Round it off, okay? This is the exact answer. Nothing's rounded. This is the rounded off answer, okay? All right, and a couple of the variations. Try and see if you can figure out what these are, and maybe we'll talk about them in class. And that one. And that one. The gears. Every time you have a circle, they are all similar because a circle is just a circle. It has to be a perfect circle every time if you call it a circle. If it's an ellipse, like an oval shape, or something else weird, then it's not a circle. A circle is going to have one center point, and then you know, the radius is the same everywhere, so everything's going to be similar. So is the length of these gears, are these little spaces right here, are these arc lengths, are they going to be proportional? So there is a bigger one and a smaller one. Sorry about that little interruption. Alright, so they're asking about the proportional length to the radius on the thing. So if we had, let's say, 5 inches here, and this was 10 inches on the bigger one, okay? The arc length would also be that same ratio. So let's say the arc length was 4, well, what would it be? You could put a big old X right there, and these are going to be the same proportion because they're just sides. It's not areas or anything weird. It's just sides. So 5 goes with 10, small over large, the way 4 would go with X. And that X would work out to be 8. So they would be proportional that way. Next, we have the areas of our circles and sectors and segments. You just thought segments were on straight lines, but no. All right, so who wants to sit here and count all the tiny little boxes inside the circle? Not me. You don't have to, especially because some of them are just like little quarter boxes and half boxes around the edge there. No, not going to do it. I did, when I had this up on the big board, count that this is 20 little boxes going this way. All right, so that radius. So your formula, pi times radius squared, my radius is 20, and you square it. So for the ACT, of course, this would be 400 pi, because you don't put the pi in the calculator. But when you put it in the calculator, you end up with 1,256.6 little boxes. Yeah. Okay. So this will be square units. We don't know how big they are. But who wants to sit there counting all that? Not me. Okay. It doesn't seem like it'd be that many, does it? But after you start counting, you'll see. It would be a lot. All right. So a sector, what's called a sector, looks like a piece of pie or Pac-Man. See there, Pac-Man? Y'all remember Pac-Man? He ate the ghost. See? Yeah, okay. We love that game. All right, so a fraction or a piece of the circle. So we're talking about the whole circle, which is pi r squared. And this reminds you of how the formula went with the arc length. Then the degree over the 360, part over the whole. So it's like you're starting with the full circle, and then you're saying, what fraction of the full circle do I need? So just as simple, the sector area is going to be the part, the degree, which is 270, because it's all that section there, over 360, times pi times 10 squared. You can give an ACT answer for this. Don't put pi in. 75 pi or 235.6, and that would be square inches, because now this is area again. All right, let's try another one down at the bottom. Now, most of the time these are going to be shaded. Oh, I forgot about this little bitty one. Most of the time they're shaded, but if I give you a piece like this that I'm wanting the whole thing, or the whole thing there, but down here I'm just wanting the shaded parts. So the little one has 130 degrees over 360 times pi times 18 squared, of course. And you end up with 117 pi. I want both answers, or 367.6. Okay. All right, the shaded areas, now you got to do a little thinking on these. So it doesn't just tell you the degrees. I want you to go figure out the degree. So if it's going through the middle with that little dot, how many degrees is that going to be? 180. Of course you know that. Over 360. Or you can just do 1/2, because it is half the circle. Times pi times, what's the radius? Not 20. 10 squared. So you end up with, what are my notes? 50 pi for ACT, or 157.1 here. All right, and then the last one here, we've got a weird shaded area. 20 degrees is not shaded. I want all this shaded up in here. That's the rest of the circle going around. So I'm going to have to say, I need 360 to take off the 20. It's going to give me 340 for all this outside part. So 340 over 360 times pi times 18 is a radius squared. And you get 306 pi, or 961.3. And that's in inches, so square inches. Cool? Cool. Alright, so here's a little cutie I used to do. So if Rover is attached to the chain in the yard, poor dog, he gets to run around in a space like that. So how many square inches or square feet of space does he get? That would just be a full circle formula. Full circle formula, pi times radius squared. So he gets to run around. Let's just do it in ACT form. Pi times radius squared. So that'll be pi times 12 squared, 144 pi. That's how much space he gets. All right, well, he must have tore up the yard really bad, or somebody's trying to steal him. So they moved him to the side of the house. So now, instead of a full circle, he gets a half circle. So that's more of a sector instead of a full circle. So you can do the degrees, or you can just say, hey, I know it's half times pi times 12 squared, same chain. So 144 was half of 144, 72 pi. Or if you saw that it was half of that, you could say it was half, okay? All right, then Rover must have really been bad. He must have been under a window barking too much because they moved him to the corner of the house. All right, so we're going to see he gets to run around in a 3/4 of a circle. So if you're not sure about the degrees, how much is this building right here? That's 90. And if you say 360, take off 90, 270 degrees, 270 over 360 times pi times 12 squared. And that would be 108 pi for that space. Now, he got really, really bad and loud and barking, carrying on, so they took him way out to the shed. Poor Rover. He gets to run around, a little more space though. Because watch what happens. When he runs around, he's fine. So he gets up here, and then what's going to happen when he comes around here? Is the chain going to run through the building? No. What's going to happen to the chain? It's going to go this way and then wrap around this way. And it won't be as long. So I messed it up. So it was 4 feet that way and coming out like this. And so it makes a little separate sector right there on its own. You had the 108 pi, which was like the other piece. All that would have been 108 pi. So what happens is you get this extra little piece right here. It's a new sector, and it's got a different radius. Because you cut off 4. It was 12 coming out here. You just cut 4 off. What's left over? 8. So he gets to run around 8 feet around this way. It doesn't come out as far. My drawing is not as good as it should be, but it gets shortened. So 108 pi added to 90 degrees, 360 pi times 8 squared. Let's see what that gives us. 16 pi gets added onto that. So there's a little bit extra space. So he gets 124 pi right out in the shed. Poor Rover. Okay. So our last type is segment. And this is a segment of a circle, not just a straight line, but this whole shaded region right here is what's called the segment of a circle. It is made from drawing a sector first, like the green right here, and then connecting a cord across that edge from point to point on the circle. And what's left over is that little bitty segment right there. It's really just made from 2 cords, or a cord. When you block off a cord with it, then you could always still go back and draw the radius to it, and there's your triangle. But it does have something to do with the triangle. Alright, so there's 1, 2, doing the same thing. Alright, now remember, the radius is going to match on both sides on that triangle. you don't necessarily know what the base is. And so in these cases, I'm going to make it easy and have you a right triangle. But the formula, you just saw it flashed up there, is going to be the sector area minus the triangle area. And we're going to do it in terms of pi, just to keep the decimal straight. All right, so what's the sector formula? The degree over 360 times pi times radius squared. And triangles, base times height divided by 2. All right, now watch what happens here. This has a radius of 6, so the 6 could be here and the 6 could be here, and we got a 90-degree angle right there. So the degrees are going to be 90 over 360 times pi. The radius is 6 squared. So let's put that in the calculator without pi, and you get 9. So this is 9 pi for the sector. Then your triangle, we're going to take it away, and that's going to be less. See, when you do the whole sector, a sector is this whole thing like that, like a piece of pie. But if you take away the sector, you take away the triangle, you get just the sector left over right there. I took away the triangle. So the triangle itself, base times height, and see, that's where the right angle comes in. We need that base and height to meet at a right angle. 6 times 6 divided by 2 makes 18. So your ACT answer would leave it just like this, 9 pi minus 18. Now, do you notice anything with the 9 and the 18? It's like double, right? That happens every time. So if this has a radius of 10, it would be the same kind of setup, 90 over 360 times pi times 10 squared. And then for the triangle, you'd have 10 times 10, okay, because the radius is 10, divided by 2. So this makes 50. Well, this over here makes 25 pi. So you see how that relationship happens? That happens every time you do a sector, if you're going to leave it in terms of pi. Now, if you put it in a calculator, it's going to give you just whatever crazy decimal it is. So, just a little quick something extra.